Good morning, grade 12 students. In this session, we're going to continue what we have started before about the genetics exercises, the genetics worksheet, which is revision worksheet 1. Before we solve exercises from 1 to 5, now we're going to continue with question number 6. Question number 6, as you know, all of these questions, they are official exams, so we're working step by step to solve these official exams together, to discuss them together, and to identify some of the tricks in the exams and the way of answers and so on. So here in this exercise we have analysis of partial karyotypes and the framework of studying human chromosomal abnormalities. We prepare the karyotypes of parents of normal phenotype. So the normal phenotype of the parents is shown in document 1 and those of their children, which is shown in document 2. One of these children has trisomy and the other is normal. So one of these children has trisomy 21, and only certain pair of chromosomes from number 13 to number 22 are present. So they get a part of the karyotype. That's why they said partial karyotypes. So they get only the pairs from 13 to 22 for each of the parents, mother and father in document 1, and the first and the second child in document 2. First, let's have a look on the karyotype. Let's have a look at the karyotype of the father and the mother. Father has two copies of chromosome number 13, 14, 15, 16, 17, 18, 19, 20, 21, and also 22. So all of them, they are normal. So normal number of the chromosomes in the father. However, in the mother, if you want to move, 13 is normal. 14, if you look at this in 14, we have one chromosome that is smaller than the other chromosome. So one is larger than the other. 15 is normal, 16 is normal, 17 normal, 18 normal, 19 normal, 20 is normal, while 21 has only one copy. So here we have a problem in the karyotype of the mother, while chromosome number 22 is normal. So if you want to move to the fourth one, they said compare the partial karyotypes of the father and that of the mother, and then what can you draw out? First of all, whenever they say compare, I have to talk about both similarities and differences. So similarities and differences. It's not only compared to talk about differences only. So you have to talk about similarities and differences. So similarities in these karyotypes, all of them or both of them, if you want to say the karyotype of the father and the mother, both of them, they have normal or the same number of chromosomes except for chromosome number 14 and that of chromosome number 21. These chromosome pair, they are not the same. All of them, they are the same except for these two pairs. In chromosome number 14, pair number 14, they are normal in the father. However, in the mother, one of them is larger than the other. But they said in document 1 they have normal phenotype. So here, what do you have to say? You don't have monosomy, for example, but in the chromosome number 21, we have two copies in father and one copy in the mother. What explains this? This can be explained by we have Robertsonian translocation from 21 to 14. So a part or the chromosome in 21 was translocated to chromosome pair number 14, and this explains the difference in the size of chromosomes on pair number 14, and this can be explained by Robertsonian translocation, where it's translocated from chromosome number 21 to chromosome number 14. Moving now to part 2. Part 2, they said, explain why the child first child is affected with trisomy 21, and the second one presents a normal phenotype. Let's have a look to the karyotype of the first child and that of the second child. They said that the first child is affected with the trisomy 21. However, the second is normal, so there is no trisomy 21. Who can explain this? If you look to the pedigree in the first child, how many copies of chromosome number 21? We have two copies. While we have a pair of chromosome number 14, a copy of one chromosome of pair number 14 is larger or it's longer than the other. So here, one of these is longer than the other. So this can be explained by Robertsonian translocation and should be here and should have three copies of chromosome number 21. However, in the second child, we have only one chromosome on the pair number 21. However, the other chromosome was translocated to chromosome number 14. So this can be explained by also reversing translocation, but it's here in the norm. It has two copies of chromosome number 21 instead of having three copies. So this is the case here, and this can be explained by this child. The first child is affected with trisomy 21. However, the second child, it presents normal phenotype. 43. Schematize for the mother the phase of meiosis, that is the origin of trisomy 21 in the first child. They said you have to limit your answer to chromosomes 14 and 21. So you have to limit your answer only to chromosome 14 and 21 only. So here, it is the phase that is responsible for such trisomy 21, such an abnormality is the anaphase 1. So this anaphase 1, it is the cause of the abnormality. So you have to schematize chromosomes at anaphase 1, showing chromosome 14 and chromosome number 21. So one of the manifestations of the Down syndrome, which is the trisomy 21, is mental retardation. So first of all, we said that trisomy 21, it's mental retardation, one of the manifestations of this abnormality. Biochemical analysis was performed, and these biochemical analysis, they relate this manifestation to an abnormally high level of a protein. It's called protein P in the brain of individuals with this syndrome. This protein is coded by a gene which is located on chromosome number 21. So first of all, we are talking about Down syndrome. So we are talking about trisomy 21. So whenever we talk about trisomy 21, so we have three copies of chromosome number 21. Okay? So this is relating this, the biochemical analysis, they are relating this manifestation, this mental retardation to abnormally high level of protein P. This protein P is coded by a gene located on chromosome number 21. So it's located on the chromosome pair number 21. So they said propose an explanation concerning the presence of protein P in quantities greater than the normal in the brain of individuals with Down syndrome. So you have to propose an explanation talking about the presence of protein P in quantities greater than the normal in the brain of individuals with Down syndrome. First of all, they said that this protein is coded by a gene located on chromosome number 21. So if an individual has a trisomy 21, so a higher amount of protein P will be found in this individual. Why? Because we have three copies
of the chromosome number 21 instead of having two copies. So these three copies, they can be explained that we have higher amount of the protein P than the normal, and this can be explained by the presence of higher amount of protein P, which is related to the mental retardation in the Down syndrome individuals. So here, explanation concerning the presence of protein P in quantities greater than the normal in the brain of individuals with Down syndrome. This can be explained by that the fact that the individual with trisomy 21 or the Down syndrome, it have, she have, or he has, or she has three copies of chromosome number 21. So these three copies will lead to higher amount of the protein P, higher level of protein P. So this can be explained by higher amount of protein P in the individual with Down syndrome, and thus we have the relation between protein P and Down syndrome. On the other hand, we measure the level of an enzyme. This enzyme is called superoxide dismutase, SOD. This is measured in the red blood cells of unaffected control individual, which is C in document 3. So here, document 3, they represent the red blood cells. Here we are talking about the red blood cells of unaffected control individual, C, here, and those of others in Down syndrome, in DS, Down syndrome individual. So they are measuring the level of an enzyme, which is called superoxide dismutase, in the red blood cells of unaffected control individuals. So unaffected control individual, which is C, and those of other in the Down syndrome. So the red blood cells of individual with Down syndrome, DS. This enzyme is coded by a single gene, and it's involved in the synthesis of protein P. It has a relation in the synthesis, and it has a role in the synthesis of protein P, which is found by it's coded by a gene located on chromosome number 21. The documentary shows the results of SOD measurements. They said part 6 determine with reference to document 3 the proposal chromosomal location or of the gene coding for the enzyme SOD. First, let's see here in the control individual, meaning that in the unaffected red blood cells, unaffected individual, or in the red blood cells of unaffected individual, what do we have? We have first that the number or the quantity of the enzyme SOD in our meter unit, it was 1000 in the control individual. However, this amount of SOD enzyme, it increases in the case of the Down syndrome individual to about 1500 AU. So it's times 0. It's times 1.5 مرة ونص. Okay, so here this can be explained by this gene is coded by a single gene, this enzyme, and it's involved in the synthesis of protein P. So this can relate that this is related to the individual, sorry, to the production of the protein B. So in the case of normal individual, unaffected individual, the control one, the C, we have only at 1000 AU, the quantity of the enzyme SOD. However, in the Down syndrome individual, it increases to about 1500. So this will lead to higher production of the enzyme of the protein B, and thus this will lead to a higher amount of protein P in the affected individual with Down syndrome. So this can be explained or this can be related that the gene or the chromosomal location of the gene coding for the enzyme SOD is located on chromosome number 21 It's an autosomal localization. From this document, we determined that it's a chromosomal localization. It's autosomal and chromosome number 21. So here, let's make a quick revision about what we have taken here. So we compare the partial karyotypes of the father and the mother. We said the father is normal, while the mother has abnormality. Not abnormality, abnormality, it's normal phenotype, but it has Robertsonian translocation, where the pair of chromosome or a copy of chromosome number 21 was translocated to chromosome pair number 14, and explain why the first child is affected with trisomy, since it has two copies of chromosome number 21, and one of the chromosomes in pair number 14 is longer, or it's elongated down more than the second, so it's longer than the second, so this can be explained. We have the Virginia translocation, and we have an abnormality which is trisomy 21. Moving for 43. 43, you have the schematize for the mother, the phase of meiosis. We said the phase of meiosis, uh, it's at the origin of trisomy uh, 21. So it's trisomy 21. So we have a normality at the level of the anaphase 1 in the female. Moving for the one of the manifestation of the Down syndrome is mental retardation. So it said that biochemical analysis relates this to the to the abnormally high level of protein B. So اللي بيكون عنده Down syndrome بيكون عنده high level of protein B. So they said this protein is coded by a gene is found on chromosome number 21. So they said propose an explanation. So we did this. Here, part 4, I canceled part 4. Why? Because part 4 is related, this is an official exam, and part 4 is related to something called the chromosomal analysis. And this year it's deleted from the curriculum for the exams for semester, for the exams of the academic year 2021, 2020, 2021. So it's deleted. So part 4, it's deleted. That's why and cancel port 4 from the question. So here, if we remove this, all the chromosomes they said are the same, except for the pairs 14 and 21. Here, if you mention this, you're going to take, you have a quarter for this. So if you didn't say that all of them they are the same, and you didn't talk about the similarity, you're going to lose the quarter. Then, concerning the pair number 14, two chromosomes of this pair are of the same size in the father, while in the mother, one of them has the same size as those of the father, while the second is longer than the others. So here, in our chromosome number 14, you take the quarter. Another quarter concerning the pair number 21, there are two chromosomes of the same size in the father, while in the mother, a single chromosome 21 is found and has same size as those of the father. So the number of chromosomes in the given partial karyotypes of the father, it's about 20. Why 20? If we move back to the karyotype, how many pairs do we have? So we have about 1, 2, 3, 4, 5, and here 1, 2, 3, 4, 5. So 10 pairs, so 10 pairs, 20, 10 times 2. While here we have a missing chromosome, so we have 20 minus 1, so it's 19 chromosomes. So the karyotype of the father is normal, while that of the mother has normal phenotype, shows a chromosomal abnormality for chromosomes for the pairs 21 and 14, where there is translocation of a complete chromosome 21 on chromosome 14 representing translocation. So they said the first child has trisomy 21. Why? Because he has three chromosomes 21, two free chromosomes 21, pair 21, and one attached chromosome number 14, which is translocated. The second child has normal phenotype because he has two chromosomes 14 and two chromosomes for 21. Why? Two chromosomes 21. One is free and one is translocated to chromosome number 14. So the genetic material is going to be conserved and it's going to be normal. 43 schematize the phase that is responsible for such an abnormality. So we have two chromosomes. We have chromosome number 14 and chromosome number 21. We have translocation here from chromosome 14, and it occurs in during anaphase 1. Moving to part 5. Part 5, they are talking about the individual with Down syndrome. It has three copies of chromosome number 21 instead of having two copies. So the gene coding for protein P is located on chromosome number 21. So the affected individual have three alleles of this gene. These three alleles will code for this protein, and this explains the high level of protein P in individuals affected with the Down syndrome or trisomy 21. Part 6 is that you have to explain the results shown in the figure or in the document. So in the document, what do we have? We have in the red blood cells of control individual, the amount of the enzyme or the quantity of enzyme SOD is 1000 AU, which is higher. Why it's higher in the red blood cells of the individual with Down syndrome? So 1500 in the individual, the red blood cells of the Down syndrome individual, while it's 1000 only in the red blood cells of the individual, which is the control one and it's the normal. So the individual with Down syndrome, they synthesize 1.5 times more SOD enzyme than the healthy individuals. So these, since 1000 correspond to the presence of two chromosomes, 21 in normal, and 1500 correspond to the presence of three chromosomes, 21 in the case of trisomy or the Down syndrome. So we can say that the gene coding for the SOD, it's autosomal and it's found on chromosome pair number 21. So this can be explained that it's located on the autosome and chromosome pair number 21. This question is very easy. It has simple ideas and very easy ideas. So you have to focus on the question. You have to relate the karyotypes to the figures or to the analysis that have done about the quantity of protein P and so on. You have to know that trisomy, whenever you are talking about trisomy, you are talking about high amount of chromosomes, meaning that it has an additional chromosome number 21 if it's trisomy 21, if it's trisomy 18, additional chromosome 18, and so on. So this is everything related to this exercise. This exercise is very important related to the ideas and the way of answering. So in this exercise, we determine how to answer the comparison. Whenever we have compare, we have to talk about both similarities and differences. We don't have to talk only about differences, or we have to talk about both similarities and differences. We explain the trisomy and the case of translocation, Robertsonian translocation, 21 to 14, and we schematize the origin of the meiosis, which is the anaphase 1, which is the origin of this. Okay, so here we have explained all the questions for this.